So imagine you are running a high-end kitchen right in the middle of the dinner rush.
Chaos.
Absolute chaos.
Mm.
And in the old world, let's call it the traditional automation world, you have to write down the recipe for every single dish, step by step, for a cook who has absolutely no common sense.
Right, like zero intuition.
Zero. You literally have to say, chop this onion to exactly 5 millimeters, saute for exactly 180 seconds at 350 degrees.
And if the onions are a bit bigger than usual.
The whole thing breaks,
Yeah.
the meal is ruined, the line stops. If you make a typo in the recipe, it's game over.
Yeah, that's the inherent fragility of hard-coded scripts. I mean, they do exactly what you tell them to do, even if what you tell them is wrong, or if the environment changes in a way you just didn't predict.
Exactly. But now, imagine you just look at a master chef and say, hey, we have fresh salmon and asparagus. Make me something amazing for table 4.
You aren't telling them how to hold the knife.
No, you aren't timing the sauté for them either. They figure it out, they taste, they adjust, they plate. That shift from rigid instruction to flexible outcome is exactly what we are unpacking today.
Because it is a fundamental shift in software architecture. We are moving from instruction-based automation, where you define the steps, to outcome-based systems where you just define the goal.
Welcome to the Deep Dive. I'm your host, and today we have a massive topic. We are diving deep into a presentation deck titled Agentic Evolution.
Great to be here. And yeah, this deck is a dense technical look at how AI is moving from just following orders to actually thinking its way through problems.
Specifically, we are looking at agentic workflows. And the distinction here is crucial for anyone in tech or business who's tuning in.
Right, because a tool waits for you to click a button. An agent sees a problem, formulates a plan, and fixes it often before you even know it was broken.
So our mission for this deep dive is to unpack this evolution. We're going to walk through this source material pretty much slide by slide, because the visuals here tell a very specific story about the future of code.
We need to figure out what this means for the software and perhaps more uncomfortably what it means for the humans. You know us, the people who are used to being the ones running the show.
Right.
And I think the key thing to keep in mind right from the start is that this isn't just about coding faster.
It's deeper than that.
Way deeper. It's about a change in ownership. Who owns the how? For the last 40 years of computing, humans own the how. We wrote the logic. Now we are handing that how over to the machine.
Let's jump right into part 1 then. The first slide really sets the stage visually. You've got this digital brain glowing with neural connections, and it's processing code. But the text is what really matters here. It reads the evolution of automation, from instruction-based to outcome-based.
And right next to that brain, there is a tiny snippet of code. It's subtle, but if you look closely, it is doing a lot of heavy lifting. It says agent.optimize outcome.
Agent.optimize outcome. Why highlight that specific line? I mean, to the uninitiated, it looks pretty generic.
Right. It looks generic, but it's revolutionary. In traditional coding, you don't write optimize outcome. You write if X, then Y else Z. You write the path.
Right. You map out every branch.
Exactly. But this snippet is a goal. It's telling the system, look, here's where I want to end up. You figure out the path.
And if you look at the logic right below it, the system actually checks, is status equal to success?
And if it's not, it doesn't just crash.
Yeah.
It loops, it retries, it pivots.
Which leads us perfectly to the second slide. This is a stark visual contrast. On the left side, you have traditional automation.
It looks like a stress headache, honestly.
It really does. It's a messy web of arrows, decision diamonds, and right in the center, a blinking red sign that says error 404.
We have all built that architecture. Think of a complex Zapier Zap or a fragile Python script you wrote to scrape a website.
You defined every single step.
But then the website changes its CSS slightly, or the API rate limit hits. Your script hits a wall and stops. It breaks because it has no brain. It only has instructions.
And on the right side, we see Agentic Workflows. It's just a clean, glowing green loop.
It's a loop because it's iterative. The key bullets here are self-healing capabilities, and you define what to do.
So if an agent hits that same 404 error,
it doesn't crash. It treats the error as new information.
It thinks.
Right. It thinks, okay, that link is dead. Is there a search bar? Can I find the page another way? It navigates around the roadblock autonomously.
There's a tagline at the bottom of this slide that I absolutely love. Stop laying bricks. Start designing the building.
That is the thesis of the whole deck. We are moving from laborers, people who place every single digital brick via syntax, to architects.
We design the blueprint, the outcome, and the agents do the heavy lifting of actually laying the bricks.
Oh, exactly.
That sounds great in theory, but I really want to know how the sausage is made here. How does it actually heal itself?
Let's get into the mechanics.
That brings us to part 2, the 4 pillars of agentic systems. Pillar 1 is on slide 3, the self-healing loop.
This visual explains that green loop we saw earlier. It starts with execute code, then inevitably error detected.
In the old world, the script dies right here.
Game over. Check the logs, try to figure out what went wrong. But here the arrow points to agent reads error, then agent tweaks code, then retest, and finally, success.
Wait, so it is actually rewriting its own underlying code on the fly?
Yes, it's debugging in real time. The slide explicitly says the agent fixes its own breaks.
That is wild.
Think about it like driving your car. You get a flat tire. Instead of pulling over and waiting for a tow truck, the car senses the pressure drop, analyzes the puncture, seals it, reinflates, and keeps driving.
And you as the passenger might not even notice the car fixed itself.
Exactly. You just arrive at your destination.
That is incredible utility. But I have to admit, it also feels a bit unnerving. I mean, if it's rewriting code, what stops it from rewriting something critical? Or building something I didn't actually ask for?
That is a very valid fear, which is why Pillar 2 on Slide 4 is so important, natural language and scope.
Okay, let's look at this one. The visual here is a chat bubble. The user says, build a lead gen tool.
A short, vague request. Usually a total recipe for disaster in software development.
Yeah, if you gave that command to a basic script, it would fail completely.
Precisely. But look at the agent's response in the blue bubble. It doesn't just start coding blindly. It halts and asks questions.
It says, understood. Before coding 1, who are the specific users? 2, what is the geographic scope? 3, how should we handle edge cases?
It's pushing back. It's acting like a senior consultant.
It really is.
It's the interview phase. The diagram shows the flow user request to scope analyzer to requirement extraction to system blueprint.
So it's refusing to build until it fully understands the constraints.
Right. It captures the vibe and the exact scope before it writes a single line of code.
So it prevents you from building the wrong thing.
Which, if you have ever worked in software, you know is the most common cause of failure. It's rarely that the code doesn't run. It's that the code solves a problem nobody actually has. The agent ensures alignment first.
Okay, so it knows what to build. But is it safe? Slide 5 introduces Pillar 3 automated security. And the persona they use here is the security-obsessed developer.
You absolutely need this layer. If you have an autonomous agent executing code, you have to have guardrails.
The slide emphasizes continuous review.
That means every single chunk of generated code is scanned for API leaks, or PII, that is personally identifiable information before it even runs.
I really like the natural language guardrails listed here. They aren't complex rejects, patterns, or confusing syntax. They are just plain English rules.
Read a few of them.
Rule 1. Never send phone numbers to third parties. Rule 2, halt workflow if API usage is greater than $5.
That rule 2 is the one that saves your bank account, man.
Absolutely.
Imagine an agent gets into a loop. Maybe it's trying to self-heal incorrectly, and it just starts pinging a paid API 1,000 times a second.
Without that guardrail, you wake up to a massive $10,000 bill.
Exactly. These rules decouple the builder from the inspector. The agent builds, but a separate protocol inspects the work against these hard rules.
So the inspector is basically the buzzkill that keeps us safe.
That's a good way to put it, yes.
Yeah. Let's hit the final pillar on slide 6, instant integration. It mentions something called MCP, the Model Context Protocol.
This is a huge unlock for interoperability. The visual contrasts the old way, manual configuration, auth headers, fighting with JSON formatting with the new way.
I feel personally attacked by the JSON wrangling comment. I've spent hours just trying to get the bracket formatting right so one API can finally talk to another.
We all have. It is so tedious. But with MCP, as the slide shows, you just tell the agent, get my transcripts and push them to my project management tool.
And the agent just handles the handshake.
It handles the handshake. It already knows the standard for talking to Google or Slack or Stripe or HubSpot.
So it's like a universal adapter.
Think of it like a USB port. Before USB, we had a dozen different ports for mice, keyboards, printers.
Right, the big chunky parallel ports.
Yeah, exactly. MCP is the standard that lets the agent just plug into your tools without you needing to wire the outlet yourself.
Okay, so those are the pillars: self-healing, scoping, security, and integration. But how do we actually structure this? We can't just toss a large language model at a server and hope for the best.
No, definitely not.
Part 3 of the deck introduces frameworks and live builds. Slide 7 details the WAT framework, W-A-T.
This is the anatomy of a reliable agentic system. W is for workflows. Those are the SOPs, the markdown files that define the process logic.
The rule book, basically.
Right. A is for agent, the brain. This is the LLM like Claude or GPT. It does the planning and the reasoning. And T is for tools, the hands. These are typically Python scripts for deterministic execution.
I want to pause on that distinction for a second for everyone listening. Why separate the brain from the hands? Why not just let the brain do it all?
Because brains hallucinate. Hands do not.
Explain that.
LLMs are probabilistic. They are essentially just predicting the next word based on patterns. If you ask an LLM to do complex math or scrape a specific CSS selector on a website, it might just guess.
And it might be right or it might be confidently wrong.
Exactly. But a Python script, it's deterministic. 2 plus 2 is always 4 in Python. The Watt framework separates the reasoning deciding what to do from the execution actually doing the math or the scraping.
That's a critical distinction. The agent is the manager. The tools are the workers.
Correct.
Let's see it in action on slide 8. Live build lead gen automation. This is a flowchart of a real-world task. Find Chicago dentists.
A classic sales grunt work task. Let's trace the path here. The first step is plan. The agent decides, okay, to find dentists, I need to query the Google Places API. It writes that plan down.
Then it triggers tool 1, the scraper.
Yeah.
This is a Python script.
Yes, and notice the agent wrote the script or selected it from its toolkit. The script goes out, hits Google, and comes back with raw data.
It doesn't hallucinate the dentist. It actually fetched real listings.
Right.
Then tool 2 takes over. This is the outreach writer and LLM. It looks at the data, let's say a Dr. Smith with 4.9 stars, and drafts a custom message. Loves your 714 reviews.
So here we actually want the creative brain because we need personalized human-sounding text.
Makes sense. And finally, tool 3 sheets export. Pushing that structured data into a spreadsheet, the slide highlights the terminal output at the bottom. Success, Dr. Smith, 4.9 stars message generated.
And the real kicker is at the bottom of the slide. 100% generated via conversation. User defined the goal. Agent write the tools.
So the user never touched the Python scraper at all.
Not once. The user just said, find dentists. The agent realized it needed a scraper, wrote the code for it, executed it, handled any errors, and delivered the result. That is the agentic evolution. It's not just using tools, it's creating them on the fly.
It really is designing the building instead of laying the bricks. But where's all of this going? Part 4 covers future trends. Slide 9 shows a radar screen scanning for blips.
This represents the massive shift from reactive to proactive systems. The slide labels the current state as reactive.
Meaning waiting for a webhook, a form submit a customer complaint.
Right. And the future state is proactive. The radar is detecting things like deal rot, project delay, and inefficiency.
Deal rot is such a great term.
It's a huge problem in B2B sales. Usually you don't know a deal is dead until the client just ghosts you for a month.
Yeah, you're just waiting around.
But a proactive agent is constantly scanning the CRM and your inbox. It notices, hey, this client hasn't replied in 14 days, and their sentiment score in the last email dropped by 20%.
It flags the risk before the deal is actually completely dead.
Exactly. It nudges you. Hey, call this person right now. It stops waiting for input and starts generating proactive insights.
The slide cites a Deloitte forecast here. 50% of enterprises will deploy agentic pilots by 2027.
That is effectively tomorrow in corporate terms.
It is. And that scale implies a whole lot of agents running around, which leads right into slide 10, the multi-agent org chart.
This literally looks like a corporate hierarchy, but for bots. At the top, you have the manager agent.
What does the manager do?
Its job is delegation and stitching. It doesn't do the actual work, it coordinates. Below it, you have specialist agents. A research agent, an email agent, a data cleanup agent.
Why split them up like that? Why not just have one super agent that knows everything and does everything?
Because of context windows and confusion. Specialization beats generalization every time. If you try to make one prompt do research and writing and coding and formatting, it gets confused.
It forgets its instructions halfway through.
Exactly. But if you have a data cleanup agent that does nothing but format phone numbers and clean addresses, it will be perfect at that specific task every single time.
So the manager agent breaks down a big goal, like launch a marketing campaign, and says, you do the research, you write the copy, you clean the list.
And then it stitches all those pieces back together. It's literally recreating a human team structure because that structure works for managing complexity.
Slide 11 takes this networking concept even further with Trend 3 A2A protocols and the agent mesh. We see a web connecting Salesforce, SAP, and Google.
A2A stands for agent to agent. Right now, to get data from Salesforce to Google, we usually put a human in the middle.
I download a CSV, I format it, I upload it. It's awful.
Right, or we build a rigid pipeline. This slide proposes an agent mesh where agents have standardized skill files.
Skill files, like a bot resume.
More like a menu of services. The Salesforce agent broadcasts, hey, I can update records and pull reports. The Google agent says I can schedule meetings and send calendar invites.
And they share a secure context so they can just talk to each other.
Yes. So the Salesforce agent can directly ask the Google agent to schedule a meeting for a new lead without a human ever opening a calendar app.
It's an economy of bots trading services.
An open standard for autonomous cooperation.
Trend 4 on slide 12 addresses a very real technical problem, though. Context window fatigue. Basically, AI forgetting things over time.
Yeah, if you have a project that runs for weeks, the AI runs out of short-term memory. It hits its token limit. The solution proposed here is the agent harness and working in shifts.
You see Shift A passing a baton to Shift B on the diagram. And in the middle, there's this glowing icon labeled Structured Artifacts, Notes, To-Dos, Diffs.
Think of it like a shift change at a busy hospital. The outgoing doctor doesn't just wave goodbye and leave.
Right, they leave a chart.
Exactly. Patient X needs this medication. At 4 p.m., vitals are stable. The agents leave structured documentation markdown files databases for the next agent to pick up.
This allows for long-running project agents that can work indefinitely without losing the plot.
Precisely. They hand off the context cleanly.
So we have these self-healing, proactive, collaborating, long-running agents. It begs the big question, which we finally get to in part 5. Where do we fit in?
The existential question.
Slide 13 shows the new role architect and manager. We see a pyramid here. The bottom, the wide base is labeled automated or commoditized.
And this includes coding, syntax, API configuration, error logging.
I have to say that hurts a little. That's the stuff I spent years learning.
It's the how. And the how is becoming cheap. But look at the top of the pyramid. Human value, logic, architecture, management systems thinking.
The slide explicitly states the implementation layer is getting easier. The value moves to defining what the system should do.
This is the critical pivot for everyone listening. You are no longer valuable because you know how to write a simple for loop in Python.
Right.
You are valuable because you know why you need that loop, where the data should go, and how it fits into the broader business goal.
Slide 14 hits this home with why your experience matters. I think a lot of people worry they're becoming totally obsolete.
But this slide argues the exact opposite.
It lists 3 key human skills: process decomposition systems, vocabulary, and failure intuition.
Let's look at process decomposition, breaking big problems into discrete steps. An AI can't easily look at a vague business problem like we need more sales and just solve it.
That's way too abstract.
Right, a human needs to break that down.
Okay.
To get sales, we need to scrape leads, enrich data draft emails, and track responses. That breaking down, that's human logic.
And what about failure intuition? The slide defines it as knowing how things break.
This is where the veteran really shines. A novice might say, build an agent that scrapes LinkedIn. An expert knows LinkedIn has aggressive anti-scraping measures, rate limits, and legal issues.
We need to use a proxy delay request or just use a completely different data source.
The AI will try to do what you ask. The expert knows what you should ask to avoid a complete disaster.
The quote on the slide sums it up perfectly. You aren't obsolete, you are promoted. A novice can make an agent work, an expert makes it reliable.
That's the takeaway. Reliability is the new gold standard. Anyone can generate code now, but generating code that runs for a week without crashing.
That takes an architect.
It takes an architect.
We've reached the final slide. Slide 15. It's stark. A black background with a glowing blue QR code right in the center. The headline reads, "The skill is communication."
The barrier to entry is dropping, but the ceiling for impact is rising.
It brings it all back to the intro. If you can communicate the logic, the recipe, clearly the agent can cook the meal.
Exactly. The ultimate programming language isn't Python or JavaScript anymore.
It's English.
It's English, but it's structured English. It's logic communicated clearly enough that a machine can actually execute it reliably.
And right below the QR code, it says Midnight Terminal End Session. A very cool sort of cyberpunk way to wrap up the deck.
It fits the vibe perfectly. We are stepping into a new era, a sort of midnight, where the old rules of coding are fading away, and this new agentic dawn is breaking.
So let's quickly recap the journey. We started with the shift from instruction-based to outcome-based automation.
moving from telling it how to telling it what.
We saw the self-healing loops that fix their own code and the importance of the Watt framework separating the agent brain from the deterministic tool hands.
We looked at the future of proactive multi-agent teams that trade services like a marketplace.
And finally, we realized that our job is shifting from bricklayer to architect managing these systems rather than writing every single line of code.
It's a lot to process, for sure.
But if you take one thing away from this deep dive, it's this. The technology is ready, the agents are capable, the bottleneck is no longer the code, it's our ability to imagine and define the systems we want them to build.
That is the most powerful realization of all of this.
And speaking of realizations, here is a final provocative question for you, the listener, to mull over as you unplug from the midnight terminal.
We talked heavily about how agents can optimize outcomes, but if the doing is fully automated, how good are you really at the defining?
If an agent can build literally anything you ask for, the limit isn't technical skill anymore.
It's the quality of your questions and your logic.
Are you ready to stop laying bricks and start designing the building? Or are you still out there trying to perfect a recipe for a chef who already knows how to cook?
Something to seriously think about.
Thanks for diving in with us today.
See you in the next build.